The next topic is converting between concentration units. I could give you any concentration unit as the start and ask you to turn it into any other concentration unit. These problems, for example, here's one where you have a 0.258 mol solution of glucose. The density is given, and you're asked to find the molarity of this solution. All of these problems, you want to start with a certain amount of solution to analyze. And the way you do that is you write out the fraction that you know. In this case, we know it's a 0.258 mol solution. And we write that not just as 0.258 mol, but in terms of the definition, which is moles of the solute, glucose, divided by kilogram of the solvent, and the solvent is understood to be water if it's not specified. So we can choose whatever numbers we want to make this fraction equal 0.258. And the easiest number to choose is 1 in the denominator, which makes the numerator 0.258. That's the fraction that we know. Then we write the fraction that we want. The fraction we want is capital M, moles of glucose divided by liters of the solution. So if we can figure out the two parts, numerator and denominator, we'll have our answer for molarity. The key to this technique is assume that you have whatever is in the denominator of the known fraction. So in this case, we're going to start by saying we're analyzing 1 kilogram of water. If we have exactly 1 kilogram of water to analyze, we must have 0.258 moles of glucose. That gives us a place to start, which is helpful because moles of glucose is half of the work in this problem. If I make that starting point, I know I already have the numerator, 0.258 moles of glucose. I simplified the problem, and all I need to figure out is the liters of solution. Again, remember that you have this formula, very helpful. Grams of solution is grams of the solute, in this case glucose, plus grams of water. We need that because we have to find out about the liters of solution, the volume of the whole solution. To get there, we're going to have to use this formula. And we're also going to have to use the given density of this solution. So by assuming we had 1 kilogram of water, we know that we have 1,000 grams of water. The grams of glucose we can get because we know we have 0.258 moles of glucose. And 0.258 moles of glucose can be turned into grams using the molar mass. 1 mole of glucose, 180.18 grams. So the grams of glucose is 46.49 grams of glucose. Since we know the two parts, the solution is the sum of those two, and we know we have 1046.49 grams of the solution. If we know the grams of solution, we can turn that into what we want, which is liters of solution. Because the problem gave us the density, and we're going to use that as our conversion factor. 1.0173 grams of the solution is equal to a volume of 1 milliliter, and 1,000 milliliters is 1 liter of solution. So we get 1.02869 liters of solution. We have both parts that we need for the molarity. We knew the numerator was 0.258 moles of glucose. We just found the denominator, and the molarity is 0.251 molar. Notice capital M, molarity, and little m, molality, will be close if the solution is aqueous, and the more dilute the solution is, the closer those two numbers are to each other.